Yours.
Thank you very much, Mark. Thanks for having me here today on the session. Welcome, everybody. It's indeed a very hot topic. My background is in engineering. I'm an engineer by education, specialized in robotics, AI back in '92. And so I've been basically following the world and being active on the level of data and analytics for the last 30 years. If okay, I'm going to start my presentation. And as mentioned, I'm very much looking forward to the questions afterwards. Let me just do this. Can everybody see the presentation? I assume so.
Yes,
Okay.
yes.
Okay, excellent. So what I'll bring is an extract from my book, a book that was launched already 2-3 years ago, but seems to be, reactivated with the arrival of generative AI. Now, we all know that this logo has been, changing our lives, I think, for most of us. If we look at the logo and we would ask ourselves, what do we see in it? It's the logo, for those who wouldn't know, it's the logo of ChatGPT, OpenAI. If we ask ourselves, what does it mean, this logo? Well, if you listen to what you read in the press or if you listen to videos, they will claim, well, we are going to create solutions that are going to create partnerships for humanity. So AI for good. And you could see in this logo, like partnerships, like people working together. If you're really into the AI expert world, we know that there's actually a different definition to this logo. And I will just explain you what it is. It's an O and an A that are intertangled, and it stands for Alpha and Omega. We want to rule the world. And that's basically the game that's happening behind the scenes. It's the game that we don't always see in the newspapers. And that's also part of my story. So my story will be a very balanced story on where AI does bring a lot of value, because I continue to embrace it even after 30 years. I think it's a fantastic technology, but I think we need to look also behind the scenes to how it works and where it doesn't work. If you compare to other technologies in our daily lives, you could say, well, think about the microwave. Microwave, we all know how it works. We know how to use it correctly, which material to put in it, which not. But do we know exactly the physics of this microwave? Maybe some of us do, but to be very honest, I don't. So to a certain level, we also have to make efforts to understand AI, because we are overwhelmed literally on a daily basis. Every newspaper you open up, it's about generative AI and the risks of it and the fact it's going to take jobs, etc., which is of course very helpful, because what you see here is that it creates a lot of tension on the line around the technology. What we tend to forget that these type of press releases are only 3 months old. But before that, there was a time where the press releases were slightly different. I mean, you see here press releases from the middle of last year, for example, with Tesla. A Tesla director who just leaves Tesla because he starts to having doubts. You see companies like IBM in the last 2-3 years saying, well, we are actually going to stop with facial recognition. Or Google and Uber, which are all not very small brands, that suddenly stop developing certain parts of AI. And you can say, well, what's happening? On one side, we have this generative AI, which is like overwhelming us. And on the other side, we have these critical voices. Well, there's a very good point that Mark raised in the beginning of the introduction, is the fact that AI is so overused terminology today, which covers many, many, many subdisciplines. And because we all put it into one word, it becomes very difficult to the external world to understand, what parts work, what parts don't work, and in which context they don't work or they work. And so this is what I'm going to demystify in my session. And because why is it important? Not just to say, well, I don't need to know this, I'm just going to use ChatGPT. Well, the fact is that behind our back, those people understanding it, the engineers, the AI, data scientists, etc., as always, those understanding the technologies already know how to go around it. I mean, it was Facebook that came out with pullovers which contain certain pixels. If you wear them, well, there's no security camera that can detect you. We will see this later on. We had students at the KUL. They knew very much, okay, if I'm going to send in my CV and I want to have the top job, I know exactly how this AI, classification algorithms work. I know how to do and what to do in order to change my CV in that way that I'm going to be on the top of the pile. To be very honest, these students have all received top jobs because they were invited because of the fact they understood how AI was going to look at their CVs. We have recently not only banks that are being tackled with cloned voices, but we also had a family in the US recently who received a call from their daughter saying that she was kidnapped and people wanting to have money. It was a cloned voice. So this is the world we're in. Because we are all still trying to understand how it works, we tend to forget that those people understanding it are misusing it against us. Now, you can say, okay, that's fine, but we've been using the words AI quite a lot. What is it? Well, it is sort of annoying to say as an engineer that it is still very much an academic discipline. It's only 70 years old. It started in around the years 50. But it's a discipline where we didn't take time to make definitions or to create a glossary of terminologies. It's nothing like, let's say the medical world, where we really have taken time to, give a name to every single bone in our body. No, we're in a world where, we can invent the definitions as we go along. That doesn't help, of course, to understand each other. It's sort of creating the Babylonian speech confusion, because people might be sitting in a room talking about the same word, but having a different meaning to that word. That doesn't help, of course, to follow up with this presentation. So let me use a definition that's most commonly used if we talk about AI today. And we can say that AI is a system that has the ability to learn by itself, to see patterns in data by itself, to see changes in patterns by itself, but by looking at a huge set of data. So it gets data from which it can learn, and it can see in that data, it can see certain correlations, some changes in that data, and from there on, it can make predictions towards the future if a new data set is proposed. This is what I would just commonly call right now AI. I know for the nerds in the room, this is not the exact definition, but to the common public, this is what it is. It's a system that can learn by itself by looking at a huge set of data. AI went through a couple of ups and downs. We call them the winters and the summers of AI. The summers are those moments where investors say like, whoa, this is top. We're just going to invest in it. But then it fell down. So you can see it, we had 2 winters before, and that's because mainly at that time, either the compute power wasn't available or there wasn't enough data, which means that the technology worked, but the accuracy of the decisions that the system was making, or the accuracy of the insights the systems were making, wasn't high enough in order to make it useful in our daily lives. Now we see a big growth from 93 onwards, and that's the time where, or that's the year where the internet was opened up to the right public. And the internet came with a lot of data. It came with pictures, images, click behaviors, etc. It's also the moment in time, if you look it up in Wikipedia, where companies like Google, Amazon, etc. started their first steps into AI, because they immediately understood the value, what it can bring to a data-driven economy. So that was in 92, 93. So it became really, to many companies, a profit generator. It became a way to tackle either cost in a company, to decrease cost, to increase revenue, or to decrease risks. And these are the 3 KPIs from which a company needs to live. So that actually happened very well, and others started to copy those big companies more towards 2000, 2010, etc. So we've seen this explosive growth, and I could say, well, okay, but that's fine, but where did we see then these tasks being picked up? Because there's quite a lot of tension on the line saying that, this AI is going to replace our jobs. Well, to be very fair and honest, we've seen this in the mechanical engineering world as well. When the robots arrived, any type of automation always changed jobs. There were jobs disappearing that were taken over by technology, and there were new jobs created. That was always the case when new technology entered our daily lives or our companies. So this is no different with AI. Some jobs indeed will be replaced by technology, AI technology, but there will be places of new jobs that are going to be appearing. Now, you could say, okay, that's great to know, but which jobs will be changing? Where will the AI be taking part of our daily lives? And where will it actually help us? Well, the easiest way to do it is to compare it to the letters D in English. So first of all, I think we've all seen AI in an environment where it can replace dull tasks. Those tasks are basically those tasks that don't give a lot of energy to people. They're very repetitive. They don't request a lot of strategic knowledge, but they're very repetitive and time consuming. For example, typing over an invoice from one system into another system. Well, let's be clear and fair to AI. Image recognition and text recognition will process these documents much better than what a human can do. It's been proven that the quality in a high level of document processing is better done by AI, by the technologies I mentioned. So there, I would say we can be, we can be at ease with AI. Difficult tasks. There are many tasks in our world where we have some uncertainties, where we are not absolutely sure what's happening, because there's just too much data to process and to get insights from. We as a human, we can take two-dimensional data, we can take three-dimensional insights, but when it gets to 4, 5, 6-dimensional data sets, or when it gets to a data set which has too many lines and too many columns to see patterns in there, our mind is blocking. It's very normal. That's not what we're made for. However, AI, as long as it has the compute power, it can crunch the data. It can see patterns in there. It can see changes of patterns in there. And it can do that almost in real time. Fraud detection, for example, if I pay with a credit card, I leave my credit card on the table, somebody else picks it up and tries to pay with it on an e-commerce website in the next room. Well, you can actually in real time detect what the location is of my mobile phone towards the location of that laptop in order to say, well, this is most likely a fraudulent transaction because it's not a standard behavior to have both separated. That's something with a human eye, you could never, ever do, even if you would have the data. So difficult tasks in different sectors, let's give it to AI. Let's have AI helping us to relieve some uncertainties in our world by seeing insights that we can't see with our brain. We move on. If we look into dangerous tasks, the third D, well, there are moments in time, and I'm just taking one example here from Belgium with Sioen Industries, where there's moments in time where people try to do their job in the ultimate best. For example, here, a fireman who needs to help the victims in a fire. Well, at the same time that he helps victims, he also has to think about his own safety. That costs energy, because you non-stop have to think, is it getting too hot? Is it getting too dangerous from a gas level? Should I leave the building right now? All those things can be automated, because what Sion Industries has done, they have put smart sensors in these outfits, and these smart sensors will do this thinking for the fireman. They will measure the gas, they will measure temperature, etc. And in combination with smart algorithms, they will just keep the fireman at the place to help the victim and alert him only at the point of time that he needs to leave the building, which saves him a lot of personal calculation energy in his brain to really help the victim. So that's a very nice way to show how AI is not replacing the job, but it is helping the job, both from a safety perspective as from a time perspective. Also dirty tasks. If we look, and I'm not sure if somebody of you has already been to these waste management plants, it's a very interesting environment, but if you look at the problems that they have, it's mainly related to explosions. Because in this waste pile that you see here, there might be gas bottles, there might be batteries that can explode. Now, our human eye is limited in seeing those. And we have the man trying to pick up these piles and putting them on the belt. Well, we want to protect him from having this explosive environment around him. So what you can do here is, and it's also done in the Belgian project, is that we are going to work with X-ray cameras and hyperspectral cameras, enforced with algorithms who will see through the pile what's sitting in the middle. And so in a moment where there is a potential risk of having this battery in there because the system detects it, well, the person in the truck will be informed, and he will just be asked to remove that before starting to process the pile. So it's a way, again, not to replace his job, but make sure that his job is going to be safer, in a safer environment to work in. Here, it's a very nice example of dirty. Now, what you see is that these are all tasks and jobs that will continue to be developed also in the future. Very nice ways of not replacing it, the human task, but augmenting it from a part of intelligence. But then you can say, well, Mika, this session was all about generative AI. I didn't see the words yet. Well, in the generative AI really was publicly coming up at the end of 2023 with ChatGPT. I see there's a tiny typing mistake here. We call it also general purpose AI. And why is it? Because for the first time in life, this AI is no longer somewhere used in a company like you saw the examples before, but was made available in a very accessible way to the general public. What we also see, and that's why I put 2 bullets up there, is until now, Europe was doing pretty well in the development of these AI systems. The cases you saw before are very much linked to our European continent, even to Belgium. But suddenly with generative AI, we see that we are no longer part of that game. And we have the AI elite, the hyperscalers, the Googles and the Microsoft, etc., that have the compute power to work and crunch on big, extremely big data sets. We are no longer there. We see that in Europe, and it will become important later when I talk about European AI Act. We see that we actually have been reduced to a user of the system, no longer a creator of the system. And that also means that the power at the moment at that level is in the hands of AI elites, and we need to question this. Now, you could say, well, okay, but I didn't hear anything about generative AI in the examples you were giving. Well, I have to say that until recently, I was always talking about the 4Ds. Also, my book talks about the 4Ds: dull, difficult, dangerous, and dirty. Generative AI, I started wondering, but where does it fit in these tasks? Because it's not really a dull task where it helps. It's not a difficult task, to create images or to create text. And I realized, I looked up in the dictionary and what would be the word that fits to that? And I realized that actually DALL-E is a perfect word, because DALL-E means that's a slow task. It's not a task that annoys us, but it's just taking a lot of time. Just imagine that you're in a marketing department and you need to take pictures of your product in different sets, in different scenes, in different environments, in different weather conditions. Well, that would just be a time-consuming task before you can go back to your, if, for example, a marketing agency and you want to go back to your customer, it would just be a time-consuming task. Well, this is a place where generative AI, I use it also, I'm going to be honest, on a daily basis. I use ChatGPT to prepare me some text, which I will then later on correct myself or add myself. I use it to create pictures, also just to speed up some time that I don't always have in my life. So this is what generative AI will do. Now, you can say, well, Mika, this is great, but you've moved on from your definition you just gave earlier, because I was saying that it's a system that actually learns from data, from changes in data, etc. It creates insights in things that we don't directly see with the open eye. And that's, sort of comparing it to the human brain. But we've extended this definition. You could see this in the examples I was talking about, smart sensors, etc., and about autonomous actions. And basically what has happened is that in the last 10, 15 years, we've actually extended this definition also based on what we see in our human body. Our human body has different sensors on it. We have the vision, we have the sound, we have our ears, we have our mouth, etc. So we have different sensors that actually capture information and send that information straight to our brain. Our brain analyzes that information and makes a decision. If I see a lion and I'm in, for example, in the zoo, I don't need to run. If I see a lion and I'm somewhere in the middle of Africa, yes, I do need to run. So our brain actually looks at the context and the insights it gets and then sends this information to our actors, our legs, our arms, etc. Well, because it was technically possible to do this and to automate this, we actually have completely automated the cycle. We are now talking about autonomous decisioning systems that are also working with data input using smart sensors, and it could be our watch, could be our robots or our cars, or even a personalization of a website. This data is automatically pre-processed and sent to the AI algorithm. The outcome of the AI algorithm is then translated into a decision. Bring this content online. Yes, stop now directly with this car. These are all autonomous decisions that are made. Now, but what you see here, and why do I give this slide, is that this is also where the dangers or the limitations have started. Because there is no human more in the loop. in my time in 92, when I created my AI systems, I had to type the data in there. I had to manually pre-process it. And the outcome of my algorithm, I had to go to business and say, yes, my algorithm says it's 0.85. So that means, yes, you have to do this or you have to do that. Today, there is no more human in the loop. This is all automated. And to be very honest, if AI goes wrong or misbehaves, as we sometimes see in the newspapers, it's on the decisioning layer. It is not on the intelligence layer, or not always on the intelligence layer. So that's the first point. So there's no more human in the loop in our autonomous systems. Plus, on top of that, AI has been reduced to a hidden technology. A hidden technology that's in the solutions we're using. ChatGPT, we don't know, even the AI experts don't know exactly which data has been used in the pre-processing part and the pre-training part. We don't know. It's a complete hidden technology that only to a certain level is made transparent to the external world. And so these are the two challenges that we need to solve. Because today, and I was talking to a company yesterday as well, and they confirmed these numbers, if we have 100 companies that are starting with AI, we see that only 25% are able to put it into operations. I call this in my book, I call this the PPP syndrome, and PPP stands for Pilot, POC, Prototype. We see a lot of companies, because of the hype of AI, that say, well, let's just start with a pilot project or a little POC. That seems to work very well in their lab environment, but then they want to put this solution into their operational environments, and it fails. It doesn't work. Immediately you get the calls from the C-level saying, well, Mika, your AI doesn't work. Well, it's not the AI that doesn't work. The data and technology, trust me, that has been proven. It's most of the time, it is because companies forget to think about the people and the process layer in order to integrate it correctly into their more complex business processes. We will look into this afterwards. 35%. 35% refers to a number from Amazon, who said, well, our models misbehaved during Corona time. Now, we all know that Corona time really requested from us as a human to adapt to changing conditions. We had to come and work at home. We had to, do our, our shopping in a different way, etc. So we changed our behavior. We were adaptive. Now, AI, most of the models are pre-trained on data from the past. So which means they're trained on a context that might be different from the context we are living in today. That means that if you're going to use these systems, they're going to misbehave because they don't understand this context. You have to really make sure that you retrain your systems on a changing environment. I give an example here. Barco had a fantastic system on one of their medical devices, which worked perfectly well in hospital A. They installed it in hospital B, and it didn't work. Well, it didn't work simply because of the humanity, which was different from in the one hospital to the other hospital. That means that you have to retrain your system in order to make sure it adapts itself to the environment where it is. It's one of the most common mistakes is that we install AI systems, and in a changing environment, a changing context, they aren't really followed up or retrained. And the last but not least, something that's very active now also, I see Europe picked up into this last week, is 2%. There are different numbers. It's always about, taking the right statistics. But it basically means that we tend to forget that our AI systems consume energy. They use battery. And 2%, that was a number from McKinsey, is indicated as being directly related. So 2% of CO2 emission is directly related to our AI and IoT systems. And if we don't do anything about this, it'll be 20% in 2030, which is, of course, not acceptable if you think about our sustainability goals. Well, if you look at these numbers, you can say, well, what should we do? Should we just stop with it? No. I mean, to be very honest and fair, AI is there to stay in our lives. AI has proven value, has proven profit to many companies. It's just a matter of fact of making sure that this technology sticks within the boundaries which will indicate that a technology is accepted by the external world. And what are these boundaries? Well, very simple. It is that we can look behind the profit that these systems are bringing, and that we can make sure that these systems also take into account our people layer, so they have respect to the social foundations we've installed in this world, but additionally also that they don't tackle our planet, that they're also looking at the impact that it can have from an ecological point of view. very fair, this is normal in technology land. Technology land is very much driven by the fact that technically something is possible, and it's only later on when we look behind the profit. Think about the car in the 1950s. The car in the 1950s was purely focusing on profit. It was bringing us faster from here to the beach on a sunny day. It's only later on that we started to look at the impact on people, because these first cars didn't have a driver's license, they didn't have seat belts, they didn't have side mirrors, etc. And they caused a lot of accidents. Well, people started to work on this framework in order to make sure that the technology would land correctly on our roads. Additionally, in the last years, then we also started to work on the motors, because we realized the motors of our cars weren't that good for planet. So also here you see that it was a technology that first was installed in our world from a profit side, and then we looked at the people and the planet side. So that's the same thing that we have to do with AI. So we have to embrace the profit, but we have to make sure that people and planet are correctly protected as well. Then you can say, okay, fine, I get this. But where are we? We are 2023. So 70 years, still very much an academic discipline. OpenAI, ChatGPT, don't forget, that was directly launched from an academic lab or a research lab into the world. By the way, small reflection, that's the only sector where this is possible. To directly leave something from a lab and install it in the world. This is not possible in the pharmaceutical sector. It's not possible in the food sector, etc., because we don't yet have a regulation. But if you would say that, okay, 70 years later, with this academic environment, where are we? What have we done where we can be proud of? Well, to be very honest, there's a couple of points where artificial intelligence really has proven its point. First of all, the speed of processing and the accuracy of insights when it gets to very big data sets, as I have given you before. Just another example, if you take Barcodemetra product, which will detect skin cancer, well, it does it with a higher accuracy than a dermatologist. And why? Because the number of examples it has been trained on, images it has been trained on, is much higher than what a dermatologist can see in his life. So we give this to AI. If it's, to help us in uncertainties, it does work. Additionally, AI, I think that's very normal. It remains a tool. It's a computer program, little computer program. You can download it from one laptop and upload it in another laptop. With our human intelligence, we can't do this. This is, I think, very normal. Can't download my knowledge and upload it into the knowledge of my daughter, of my husband. Additionally, this AI, as it is a tool, as it is a little computer program, it needs electricity or battery. As long as it has electricity or battery, it continues to work 24 hours, 7 days on 7 days. We, with our intelligence, we know that we're only very reasonable intelligent if we go and sleep. We have an on and an off modus. So that also means if you turn it around and you say, well, I have people that are scared of AI, well, you just inform them, keep telling them it's a tool, switch off the battery, switch off the electricity, take out the battery, it stops working. We need to be more critical about this and not position it as something that was created by nature. We control it, we created it, it's a tool. But then look at the other parts of human intelligence, which aren't always that highlighted in the newspapers that we see. The size of our storage, and look at our brain, how intelligent we are. We can drive, we can recognize faces, we can read text, we can communicate, etc. with a very small size. Look at the big service that we are needing, even just only for ChatGPT. Additionally, our brain is doing something fantastic when it comes to energy usage. We as a human, for those people reading Kahneman, thinking fast, thinking slow, we're actually lazy when it gets to energy usage in our human decisioning. But it's fantastic. It is actually a world we should be learning from more and more to understand how we can also reduce the energy consumption by our AI systems. Our brain does this perfectly. Parallel processing refers to the fact that when I look at the world, I actually have my different sensors active all the time, and they make one model altogether. And AI, we'll see in an example later on, it just doesn't work like this. And then there's many, many, many more points where we can say that human intelligence, to be very honest, is still very much an advantage to artificial intelligence. The session is about generative AI. Well, just look at line number 11. That's the only thing that ChatGPT is tackling. Human dialogues is trying to put that cross a little bit more to the right, but it doesn't tackle any of the other crosses that are also part of human intelligence. Point 15 and 16, we both fail. we as a human in our decisioning, we have bias. We have noisy decisions which might depend on our, our state of mind on that day. If we're positive, we might decide to the left. If we don't have a good day that day, we might decide to the right. As these, very subjective decisions, and the bias is mainly referred to the fact that we have ideas about gender, we have ideas about age and about maybe skin color, etc. As these bias has been used in decisioning in the past, and these data from the past is now used to train the systems. Well, yes, our systems are biased. Our systems don't handle noise data very much. So we need to be aware of this, that if there's a risk that there's bias or noise in the data, in the system, or in the decisioning, and we've used this data to train our environments, that our systems are not objective. They will have these human errors in there. So you need to fix the human first before fixing AI. Now, let's move deeper into that brain. And an example we've been given quite a lot is that this is chapter number 4 in my book, is unknown, or not a lot of people are looking into this. But if you simply ask, just to give an example, Siri, what's the weather going to be like tomorrow? Or Google Assistant, hey Google, what's the weather going to be like tomorrow? The fact that behind that question, there's a CO2 emission, you can say, but where do we get there? I don't see it. Well, remember how I mentioned that it's a hidden technology. On a daily basis, some calculations say that we use about 200 hidden algorithms on a daily basis on our laptops, on our mobile phones, on all our devices that are connected to the internet. And we tend to forget that there is actually algorithms that are in there that are doing the smart answers we are getting. So in the case of Siri, what's the weather going to be like tomorrow? It basically is a voice question that needs to be translated into text. So that's first algorithm, a speech-to-text algorithm. This text has to go over to the US, where the big weather algorithms are running, and where they're asked to answer the question, hey, in Belgium, there's a session going on, and they're wanting to know what the weather is going to be like. This huge algorithm has to turn and has to send back, yeah, it's going to be sunny. Sunny has to come back, a little bit of data transfer, and then the text needs to be returned into speech because we've asked here a voice question and we want to have a voice answer. We don't actually always realize that when we're doing these tasks, when we look up information on Google, when we send an email to our for example, organizer to say thank you for this session, that behind the scenes that there's CO2 emission. Any device connected to the internet, any device using a battery or electricity to do smart things will have an impact, a direct impact on nature. Another example we give a lot is that leaving the lights on in the room is worse for planet than, leaving the lights on in the room is better for planet than switching them off over voice control. And why is this? All those systems based on voice control actually non-stop on standby. They non-stop are using a little bit of energy just to be sure that they understand at what point in time you're going to ask a question and when not. This is a topic which becomes very more important because of the sustainability goals that we have set. Now, when we look deeper into that brain, and so this was referring to the energy consumption of brain, it's also very interesting if you Google for it. It's a question on Google, or Google Translate to translate the text is worse for planet than just to do manually itself. So many people use Google Translate to quickly translate a text 2-3 lines into French or English. Well, it is worse for planet to do that through Google than just to quickly do it yourself. Just think about it. It's critical thinking is what's needed around AI. When we go further, and we're born, there's nobody teaching us, to create that brain. That's automatically done. And we actually do some smart things. We create common sense when we start looking at the world. And to the left, you see, for example, the number 8, and it's for us when we grew up as a child, it's a number between 7 and 9. We can calculate for this. Well, AI, and then now specifically refer to image recognition. I think my slide deck has gone. Do you still see my slides?
Yes.
Okay, cool. The image recognition actually will not understand this concept 8. It will basically put it in pixels and will say, well, okay, if I see white, it's 0. If I see if I see black, it's 256, and every other number is, a certain level of gray. So to what an 8 is to us, to the left, to the human eye, if you look through the eyes, and I have to put it between brackets, the eyes of an image recognition system, an 8 is to the right. So 8 to the left for human intelligence, 8 to the right for artificial intelligence. It just puts it into a digital format on which it can crunch and can work. It does not understand the left side. And so basically, this is an example from the 80s. Basically, we've given the system a lot of 8s, saying this is an 8, this is an 8, this is an 8, this is not an 8. And after a while, the system was able, if somebody else with a different type of writing was giving an 8, it was just quickly translating it into pixels, saying, okay, yeah, I've seen this type of pixel before. I'm pretty sure it's an 8 with a certain accuracy. Now, if you know that this is how image recognition works, you also understand that this has a certain set of limitations. The example before was already in the 80s. This is an example, as you see this, from 2021, not from a tiny lab. It's from OpenAI, which is a company behind ChatGPT. And they had trained the system, and then when they wanted to test the system, they realized, okay, whoa, wait a minute. If I give this an apple, it tells me it's a Greenwich fit with 85%. But if I put a sticker on this apple with iPod on there, and you put the pixel camera on, you suddenly see that the image is recognized as an iPod with 99%. This is just because image recognition does not look at the world the way we look at the world. You also see this in the example here. There's a set of pixels that are very well known. You can download them. And when you put them on a picture, AI doesn't understand. Here you see when the person puts the white in front, the system recognizes them as a person. If he puts back the picture with a fuzzy level of pixels, AI does no longer know what it looks at. So again, there are pixels out there. We are aware of this. If you have them on a t-shirt or on a device or on an object, AI flips. It does no longer know what it's looking at. And you could say, okay, but Mika, this example is a couple of years old, and that's correct. And you would imagine that some people are very worried about it and starting to work on it. Well, I can prove you, this is from 2023, you see here the date, January 2023, that this is a problem that in certain set of commercial systems is still not fixed. You see an Italian fashion designer who has created a whole collection based on these type of pixels. If you wear them, you can walk in front of any type of security camera that are installed in our offices, in our streets, and in our homes. You will not be recognized. Now, I move on because of timing. There is also the fact that when we are born, our senses work needlessly together. Our ears and our eyes work needlessly together to make a common picture of common model of the world and what's happening around us. In AI, many even of the most advanced systems will analyze any data input still separately. So every sensor will do its analysis, and then this analysis will be put together. If there's a conflict, what they will do, they will basically put a human rule on top of this. Here you see an example of an accident with Tesla, where on a very bright day like today in Belgium, white sky, you see a truck that has bent over, which is white. If you put your pixel camera on, you can say, well, I only see white, there's nothing. That's what the camera indeed did. But then there's also a sensor on this car, and the sensor, of course, detected that there was an object. But this means that in this car, in this console of this car, you have a conflict between two sensors. One saying, I see something, one saying, I don't see anything. And at that point in time, there's actually a programmer that says, well, if this happens, if there's a conflict, let's take additional data points in. Let's take the weather data in. It's on a very sunny day, so there's no mist, there's no rain, there's no snow. So there's no doubt about the camera. And on top of that, we will take the time data because maybe it's almost night, but here it's between 9 and 5, which means that there's no single point where we should doubt about what the camera has seen, simply because this camera has never learned, or this AI system has never learned, that on a very bright day, there might be a white truck that has fallen over on the motorway. So this is a limitation. We cannot simply put our whole complex world with all the things that can happen into a mathematical model. It's not just simply going to happen. I'm just going to skip this one. Additionally, if you go to if you grow up, we don't only have common sense or senses that work together in our human brain. We also make abstractions. If I see a chair with 5 legs, and then I see one with 3 legs, I see one with 4 legs, and I see a chair from a different form with 6 legs, which has never appeared to me before. I know that this is a concept, that it's an object to sit on. Well, this is very much a similar example, where we automatically make abstractions. A child of 3, 4 years old automatically understands that number 2 and number 4 are pictures of real snowmen, even if 4 is turned around. A child knows that this is real snow and that the other pictures are people that are dressed up as snowmen. If you put up your pixel camera, and you switch off any other type of intelligence, just the pixels, from a pixel perspective, there will be no difference between 2 and 3. So that means that an autonomous vehicle, the camera, detects number 3 as being a snowman. And a snowman, it has been trained on that it is an object that will never move, so there's no risk to continue driving. An autonomous car will not stop at picture number 3. This example, I always test and I am always critical to myself. I checked, and indeed, recently, Google announced that indeed, also this problem they have not solved. Halloween, Carnival, etc. are most horrible times for autonomous vehicles to behave correctly on our roads. It's the world we're in. So how are we going to fix this, to make sure that these AI systems are going to understand a little bit more our complex worlds than what they currently have? Well, we actually train these systems ourselves. When we get these ones, basically these are pictures that the Google car has been taken somewhere in other parts of the world where things are slightly different from the training set where it's been trained on. Now, Google could decide to really label these pictures themselves, but that's quite time consuming, and also that's quite expensive. So they basically pay companies to use this on their website, and these companies will then use their customers in a free way to help labeling these data. So when you get these pictures, it's not to check if you're a robot. It is basically Google behind it, who is trying to label in a very, very, let's say, non-expensive way their unlabeled data in order to make sure that their systems are going to start understanding our more complex world. Finally, when I get to the brain part, we also do something very fantastic. In our brain, we don't only make correlations, we also are able to reason. That's causality in our reasoning layer. For those who looked very well on my closed loop story in the beginning of the slides, you could see that there was a little block reasoning on there. Well, to be very honest, AI does not reason yet. ChatGPT does not reason yet. It's very good in finding quick ways and distances in words that he has learned from before, but there's little reasoning in there. If you ask ChatGPT the question, Pauline's mom has 2 daughters. Charlotte is the name of one daughter. What's the name of the second daughter? Everybody would know that it would be Pauline, because that's what I said in my first phrase. Well, ChatGPT will say, I don't have the information to answer your question. Now, to be very honest, it's a very known fact that AI, I mentioned, is able to analyze in a very smart and very fast way huge data sets, and it will find for you correlations in there. That could be in sales, in marketing context, whatever context. But the correlation is not a causality. This is a very easy example to explain the difference. But when we had our first lockdown, everybody went out to buy eggs and buy toilet paper, etc. the night before the lockdown. And of course, at the same time, the numbers were going up. So you have numbers of, the toilet paper that were sold were going up, and the numbers of corona going up. That's a correlation. That's a fantastic correlation. However, it doesn't causality. It's not because both numbers go up that there's COVID in toilet paper. Very easy way to show it to people who are not technically, but to be very honest, it's the biggest mistake that's made in companies is to, mix correlations and causality all the time. I'm just going to skip this one for timing purposes. But that basically means that we are now in a world where we have a child of a 1.5-year-old, if you compare to this. We have systems that are extremely good in certain tasks, but in very, very narrow tasks. ChatGPT might be, very impressive when it gets to human text. However, just ask it to drive a car or to recognize a mom, it will not be able to do it. You can say, okay, fine, we get this. But where does it go wrong? I remember that I mentioned the 25% of companies that are able to really put it correctly into operations. And that's because they haven't really looked into what is needed to make sure that AI lands correctly in their environments. And this is where I really compare it to a restaurant, because if you understand how to run a restaurant, a successful restaurant, you actually also know how to run an AI or a data-driven system. And how can you compare it? Well, basically, if you run a restaurant, you know that the challenge is initially is to decide which restaurant, which location, which type of customers. This is a little analysis you're going to do beforehand. And from there, you're going to buy your ingredients, your appliances, etc. You're going to invite your best cook to do this related to the challenge you have given yourself. Create the best Italian or best French restaurant. You're also going to have kitchen personnel who is going to help you making sure you get the feedback from the customers. Now, anything that I say here, you can say, well, Mieke, this is so easy to understand. That's normal. Well, it is as easy and as normal you should be running a data-driven company. However, this is also where it goes wrong. A lot of people calling me, Mieke, you're going to be happy. We found a lot of data. But a lot of data, it's the same as a lot of ingredients. It's not because you have a lot of ingredients that you're actually going to have the best running restaurant. You will be able to cook something, but on long term, just having ingredients is a cost. Just having data is a cost. This cook that you invited to come and cook, well, he doesn't like spending time on preparing the ingredients. He likes to cook. He'd like to have kitchen personnel who prepares these ingredients. That's the same with your data scientist. If you're just going to staff your team just with a data scientist, yes, he has the technical knowledge to prepare the data, but also here 80% of the time is spent on data preparation, making sure it's clean, making sure it's complete. Data degrades just like ingredients degrade. Don't give this task to a data scientist. He can technically do it, but it won't give him energy. Make sure you have a team of data engineers around him. Also, when you're going to install the system into operation, you have to go and measure. Does it have the impact you intend to have, starting from the objective you've created? And the objective you created, I want to reduce my, for example, I want to reduce my yield. I want to increase my customer satisfaction. So once you're going to define your system based on your objective, you have to go and measure. A lot of companies don't measure, which means that there's no feedback loop from the decision that you made on data and AI. It's not coming back to the team. I informed you before that AI is context dependent. So if the context of your environment change, also in your restaurant, if there's a very good pizzeria next door to where you opened up your pizzeria, your context has changed. You have to adapt the way you're going to run your restaurant. That's the same with your AI. If the context has changed, the only way to find out is to make sure that you have a feedback loop coming back into your data team and your AI team. And last but not least, a lot of people tell me, well, Mieke, we can't find anybody on the job market to do our AI projects, so we just bought a pre-trained model somewhere, and we can buy them online. Well, that's the same as just heating up a Dr. Oetker pizza in your pizzeria, because you don't know which data is being used. You don't know the quality. You don't know the context where this model has been trained. Today, there's no governance around it. There's no transparency, or not enough transparency about pre-trained models on what's in there and how they function. So use these models to get yourself knowledgeable to a certain level, or use them in order to make sure that you can start with your project, but make sure you adapt the model to your personal context. Finally, get to the end of my session. There is a moment of auto-generation. There's auto-generation everywhere around us. To be very honest, it didn't start 3 months ago. We already started seeing this 7, 8 years ago in all different forms. We saw that we were able to create systems that can create data, which was new because we had systems that could learn from data. We created systems that could decide on what they learned, but we didn't have systems that could generate data. And so we had initial systems that generated pictures, that generated text, but then we went on. We gave systems, for example, all the symphonies of Beethoven, and on a push on a button, the unfinished symphony of Beethoven was created by AI. It has been very much a lot of fun in the last couple of years. And, to be very honest, I was always in there. I was always the first one to test out new generative AI systems that were proposed. Generative AI systems, which finally also, in fact, were leading to the fake news, etc. But what I didn't always immediately realize is that these systems are very much in an open source world, because that's what people want to do. They want to share with the world, look what I can do. I can create, pictures that make automatically a zombie from you. I can do, I can create a system that can make portraits of you. I can do this A, B, C. But we don't always realize that in this open source world, that these algorithms, which are very much created for fun or for good on one side of the world, are just misused on the other side of the world. Today, in Belgium, there are insurance companies that have had the issue where they've just created their closed loop story. Remember my slide at the beginning, and said that when you have a car accident, instead of having to wait for the money to come into your bank until somebody comes along and judges if your car is a total loss, you know what? They've created a system that, without a human in the loop, is going to automate that process. That means you take a picture of your car accident, you upload it into the insurance system. AI will judge if it's a total loss or if it's just a simple scratch for which you get 1,000 euros based on training data and on what the AI system decides, and you get the payout in the next day in your bank account. Well, companies have jumped onto this. They have said, you know what, give us 250 euros, even if you only have just a very tiny scratch on your car. Give us your image. We will use a deepfake on it. You get back an image from a total loss. Use that picture to upload it in the system, and you'll be paid out 35,000 euros. This is already happening today in Belgium. Insurance companies no longer know in their closed loop story where there's a deepfake used and when there's a normal one. And this is possible because there is no governance. There is actually no regulation. This will change. We all know maybe in the meantime, or most of you will know in the meantime, that Europe is regulating AI. It will be activated in 2024. That's what our current understanding is. And Europe will just say, well, let's look at the risk categories of AI. We put it in 4 categories. The top one is China, social scoring. We don't do it. We don't accept it. The lowest one is, for example, a spam filter. That's acceptable. There's no risk in it. But then there's 2 risk categories in the middle. Today, for those who have read the newspaper, Europe has reclassified, with the arrival of generative AI, some of these categories. It also means that as long as it is not yet activated, the full responsibility and accountability when you use AI, when you produce AI, or when you buy AI is with you. You need to get a certain level of transparency and responsibility in order when you start using them or even activating these systems. Now, this is a very much a hot topic. I think Europe is deciding this week or next week to sign the document, and then things will start to get activated. It's very important. Is it perfect? No. Because to be very honest, we are in an environment where AI changes very quickly, which means that a text that was created in 2019 didn't even contain generative AI. But you could say, what is the other option is to do nothing. That's not easy as well. Has it been helpful that Europe has put it into one huge overall AI Act over all sectors, over all type of AI? It doesn't help. For me, I embrace the efforts they have done because doing nothing is no longer an option. I get to the end of my presentation. As you have seen, as AIs might be today too much in hands. Also, we've seen it with ChatGPT of people that are very much into technology, are trying to, in the hunt towards having general AI that reaches the level of human intelligence, or pushing their systems and trying them out directly on the external world. After all, what we tend to forget also with ChatGPT and other generative AI systems, there is business to be run. There needs to be, they're trying at some points and at some levels, they're trying to make us addictive because at the end, somebody needs to pay the bills for the production of these images, the calculations of these texts, etc. There's huge compute power behind it. We have seen that legal got involved. Legal is not always speaking our language as an engineer. Here you see an extract of the GDPR code. I'll be very frank with you that I have to read it 2-3 times to really understand what they're saying. They don't understand me. I don't understand them. And lastly, especially also with facial recognition and the issues we've had at the level of human rights, we had society getting involved. What you see, in fact, is that we're all sitting around the same table, but we're using different languages. I don't like to hear the point that we are AI experts. It's no longer possible in AI to be an expert on all of these topics. We need more people that are acting as a human AI translator, which means transversal over all the disciplines, and use their human skills, namely empathy and collaboration skills, in order to make sure that AI lands correctly in our society.